In this video, we're going to talk about some more vocabulary, and we're looking at some different types of data. So there are two categories of data that we're going to be interested in, discrete and continuous. And then to go along with that, there are also different types of levels of data, nominal, ordinal, interval, and ratio. And we'll see some examples of what these different types might look like. So to start out, there are two different types of data called discrete and continuous. And typically these will be numerical data, but there's an important distinction between the two types. So discrete data has a couple of characteristics. First of all, discrete data can be counted. Right, so we can sort of count out what the possibilities are. For example, how many children someone has. They could have 0 children, 1 child, 2 children, 3 children, etc. Those can be counted. The other component of being discrete is that there's a set number of possible outcomes or results. So again, if you're talking about the number of children people can have, that can only be certain possibilities like 1, 2, 3, 4, right? That number could go up fairly high, but we can't have, for example, 1.5 children or 3.758 children, right? So oftentimes discrete values are whole numbers, but they don't have to be. But there's a limited set of possibilities that can happen. So an example here, besides a number of children, you might say number of marbles in a bag, any kind of sort of number of something. If we're looking at possibilities of a flip of a coin, something like that, those would be discrete data possibilities. Now with continuous data can have any value in a certain range. So for example, with children, we said that you couldn't have 2.5 children. But if we talked about, say, the height of a child, that height can take on any kind of value. They could be, say, 4 foot 7 inches, but it could also be 4 foot 7.5 inches or 4 foot 7.2 inches. Typically, continuous data has an infinite number of possibilities, and a good example of continuous data would be any type of measurement, right? So this could be length, a time, a distance, a weight, right? When you measure something, usually you can get as much precision as you want. Now, we might not necessarily measure someone's height to the nearest 10,000th of an inch, but we could. So the real difference is that continuous data can take on any value, whereas discrete data is limited to a certain number of values. Now, one possibility with discrete data, you can have discrete data where there are an infinite number of possibilities, say any positive number. So there is an infinite number, but it's still a fixed, a set number of possible results, right? If we're talking about all positive numbers, we still can't have numbers like 7.5. All right, another way to characterize our data is by putting it into these levels or categories: nominal, ordinal, interval, and ratio. And these categories sort of go in order. So nominal is the most basic. It becomes more complex or more requirements are needed for ordinal, and then even more for interval, and ratio is the one with the most number of requirements. So nominal data is data that is categorical. It's some sort of label. This is usually not numerical data. This could be something like a color. This could also be something like gender. Right? These are both labels or descriptions of something. You could also have, say, football player numbers. Football player numbers are numerical, but their actual number value is not significant. So the second requirement, that nominal data cannot be put into a meaningful order. Even though you could put football players in order by their number, it wouldn't really mean anything. It's not as if player number 2 is somehow better or worse than player number 1. Okay, the next possible category for data here is ordinal. So with ordinal data, the data can be put into a meaningful order. So we can put the data in terms of low to high, and that means something. So an example of ordinal data might be rankings of top 10 cities. These are put in order. If there are top 10, you have the first place, second place, third place, etc. But the caveat here is that the differences between the values are not meaningful. So if we looked at the rankings of the top 10 cities, city number 1 and city number 4, well, we know that number 1 is supposed to be better than number 4, but that difference of 3 doesn't really tell us anything. There's no description or units of how good the city is based upon those rankings. Another example here would be any kind of ratings, sort of rating scales like on Yelp you've got a number of stars, or actually letter grades would come in here as well. And letter grades are a little bit tricky because if we actually talk about the percentage grade, so say you got a 95%, that is not going to be ordinal. That's going to be one of our next categories. But letter grades A, B, C, D, and F, these can be put into order, but the difference between an A and a C, for example, is not clear. Now, if we did associate those with our percentages, then we might be able to make some sort of difference. All right, next category is interval. In interval data, you still have a meaningful order, so it still satisfies the requirements for ordinal, but differences between the values are meaningful. So for example, we might have temperature in degrees Fahrenheit or degrees Celsius. We can take a difference in temperatures if we have, one day that's 80 degrees and one day that's 50 degrees. We could say that there's a 30-degree difference there, and that is something meaningful. We can interpret a 30-degree difference in temperature as representing a meaningful difference. Another example here would be a year, right? So 1900 versus 2000. The difference in those years is 1,000 years. Sorry, 100 years. But the caveat here is that there's no meaningful zero. And this is kind of a tricky one. The difference between interval and our next ratio is this difference between having a zero or not having a zero. And this can be a little bit difficult to understand. So a meaningful zero is something that indicates nothing or a lack of something. With our temperature example, there is a 0 degrees, right? 0 degrees is a temperature, but 0 degrees does not mean no temperature. In fact, we can have negative temperatures as well. So 0 degrees is just a factor of where we put our scale. With years, there was a year 0, but year 0 again doesn't mean the beginning of time. It doesn't mean no years. Again, that's just one spot in the counting of years. When we finally get to ratio data, here we still have meaningful order and differences. It has all the requirements of the other categories, but now our data has a meaningful zero value. So in this case, most of what we'll look at are some sort of measurement. So again, this could be height, this could be length, it could be weight, it could be age. Right? All of these have a meaningful zero, right? If we have a height of 0 inches, 0 inches means no inches. There's a lack of all inches. Similarly, 0 pounds would be no weight. Age 0, even though age is measured in years, age is different from just a year like 1996, in that an age 0 really means sort of the beginning of a life, or no age. The reason we call this the ratio measurement is that when you have a meaningful zero, you can make ratios have meaning. So for example, we could say that one person was twice as old as another person, or that one person's height was half as large. Whereas we can't really say that with temperature. If we looked at, say, 80 degrees and 40 degrees, it's not really valid to say that 80 degrees is twice as hot as 40 degrees, even though this number is twice as big. It's just hotter, that's all we can say. One last note about these categories. The interval and ratio categories are important because these are our primary numerical categories, and when you have interval or ratio data, you can do things like find an average, whereas we should not do that with nominal or ordinal data. So for example, if we had a bunch of football players' numbers, even though mathematically we could take the average of those, it wouldn't really mean anything. So we want to keep our numerical calculations generally in the interval and ratio categories. To finish up here, here's a problem for you to practice. I've given some types of data here, and I want you to classify each example as either nominal, ordinal, interval, or ratio. Thanks, and I'll see you in the next video.